Exponential growth is when you have a starting amount, in this case 200, multiplied by a rate, and that rate has to be a number that's greater than 1. And the reason being, 1 whole is kind of your base amount. So anything greater than 1 whole is going up. So if you multiply by a number greater than 1, it's going up. If you multiply by a number less than 1, it's going to go down. So that's how we can determine, just by looking at it, if it's a growth or a decay. So 1.035 is greater than 1, so that is going to be a growth. And if we want to find out what percent growth that is, we need to change 1.035 into a percent, and that will tell us it's 103.5%. And how is that in relation to 100%? Well, 100 plus 3.5 would give us 103.5%. So 3.5% is going to be how much it is growing, or the rate of increase for each time period. And the x here is the number of time periods. So that could mean number of decades, number of years, number of months. It could even be like every 5 years it goes up 3.5%. So how many 5-year periods, and that would be what x is represented by. Exponential decay is just like exponential growth, except the rate is going to be going down over time. So we're looking for a number in parentheses that is less than 1. So in this case 0.984, it is less than 1. So if we multiply by a number less than 1, it goes down. Now to find that percent of decrease, I'm going to convert my 0.984 into a percent, and that's 98.4%. And everything is in relation to 100%, because 100% represents all of something. So all I need to do is 100% minus 98.4%, and that will give me the rate of decrease, or the rate of decay. So that would give us 1.6% decrease. And what this means is, for every time period, whatever that might be, could be every year, every month, whatever's denoted in the problem, for every time period, starting off, that 200 would go down by 1.6%, and then it would become a new number. That new number would go down by 1.6% on the next time period, and that process would repeat. Okay, now let's apply what we just learned about exponential growth and decay to write our own equation from a word problem. So in this instance, Jeff earns a 3% raise every 2 weeks. His first paycheck was $350. What should he earn after 12 weeks? Okay, so starting off, we're going to write y equals our starting amount, and this says first paycheck was $350, so that's what Jeff started earning. And in parentheses is going to go our rate, and that rate is either going to be a growth or a decay. Now, what word is our key word here telling us about the 3%? It's the word that comes after. It's raise. So raise tells me it's going up, so it's a growth. So that's in relation to 100%, because 100% is 1 whole. So 100% plus 3% would give us 103%. And it's to the x power, but in this case I know what my time is. So it's every 2 weeks he's earning that, and then it says what should he earn after 12 weeks. Well, I'm going to assume that paycheck was for 2 weeks of work. So how many 2-week time periods will fit into 12 weeks? is what we're looking at. So it's a simple division. 12 divided by 2 gives us 6, will be my exponent there. Now, we cannot leave a percent in an equation. We always have to convert it into its decimal. And just remember that a percent is greater than its decimal. It's actually 100 times greater. So in order to convert that, I'm going to need to move the decimal 2 spots to the left. And that's going to give me 1.03. So I'm going to rewrite what's in parentheses without the percent, and that would make it 1.03 for our rate. So looking at that, let's see if it makes sense. It's a 3% raise, so that should give us a number greater than 1 for our rate, which it does. And if we continue to do this, it should give us a number that's much greater than the 350 because Jeff's earning a raise. And you can plug that in your calculator to find the final amount.